In this video, we will learn about local maxima and minima of polynomials. We say that a point a comma f of a is a local maximum point on the graph, and b comma f of b is local minimum point of the graph. If we have a rectangle within f of a, if we have a rectangle within f of a where a comma f of a is the highest value, that is the maximum value, and if we have a rectangle at f of b where b comma f of b is the vertex, that is the lowest value. So these are the vertices at the neighborhood of f of a and f of b. So local extrema of polynomials. To define local extrema of polynomials, we know that the polynomial p of x is defined or written in general as an x power n minus 1 x power n minus 1 plus and so on plus a1x plus a naught. So this is a polynomial of degree n, and the graph of p will have n minus 1 local extrema. That is, either it can be local extrema is both minimum and maximum values. So how many such total local maximum points and local minimum points will be there? It will be n minus 1. So we shall check this. So for example, if I consider p1 of x to be equal to x to the power of 4 minus x cube minus 16x square minus 4x plus 48, I will use a graphing calculator to graph this particular polynomial function. So y is equal to x to the power of 4 plus x cube, plus x cube minus 16x square, minus 4x plus 48. So now you can see this should have three maximum and minimum two minimum values. This has two minimum values and one maximum value. So therefore the number of local extremas are 3. Because the degree of the polynomial is 4, the number of local extremas will be n minus 1, that is 4 minus 1, that is 3. So in the same way, you can solve many exercise problems that are given at the end of the book. So this completes section 3.2 of the book. I will see you very soon with section 3.4. If you have any questions solving the exercise problems, I will explain to you about exercise problems if you come for the office hours tomorrow, or even if you have questions regarding the exam questions, I can explain to you, but I cannot explain how to do a problem by itself. So if you have any homework question that you have a problem with, or a quiz question, or a problem with understanding an exam to question, I will definitely help you out in the office hours, that is 2 hours. So you have to make use of the office hours to the maximum extent, so that I have some students who frequently visit office hours and they ask lots of questions, and we solve problems together in the office hours. So like 30% of the work is over. Their homework submission or quiz submission is over if you spend an hour or so a week with me in the office hours. So that really helps you instead of working all by yourself. So see you soon with section 3.4.